All right. So good morning, good afternoon, or good evening, wherever you are. So what we're going to do today is going to go through a bit of an update regarding what I found since 13 and 14. And you've seen me sort of do some of these presentations before, covering sort of essentially the versions 10, 11, and 12. And when 13 came out, I was sort of perplexed a bit because I didn't really find anything too radical in there worth doing a presentation. So I sort of skipped. And the same thing sort of was tempting to do with 14. I wasn't really finding anything too radical in there either to sort of warrant a presentation. But I still wanted to do something because it's been a while since I've done one of those things, and it's not like nothing happened. So I wanted to essentially just take the time to go through some of the things that I've seen in both of these things, and also cover some additional topics related to internals that you might find interesting. So anyway, the slides were actually, you'll see I'm done it a bit differently this time, sort of just aggregated a whole bunch of rough notes. So I'll go through a whole bunch of stuff, but anyway, the slides and the other stuff I'll make available later on. So for those of you not familiar with my work, I wrote the Embedded Linux book for O'Reilly and the Embedded Android book for O'Reilly, and I'm actively involved in helping folks take Android and put it in all sorts of wacky devices. Okay, so just a snapshot of where we're at, and then I'll dig into 13 and 14, what I've seen in those. So give you some stats. I'm not really sort of a big fan of stats, but anyway, just in case, sort of give you a bit of bearings there, sort of give you an idea of how much build time I've seen respectively each of these take. One of the things that I thought was interesting to do was to do a recap of the Android coverage or related topics at Linux Plumbers. There's a whole bunch of stuff that was discussed at Linux Plumbers that relates to Android internals, and those are the things that caught my eye. And of course, I'm going to focus on the Android Micro Conference, which was fairly interesting in several respects. Also give you some impressions of Android Studio for a platform. I played with it a little bit. I'll explain to you later why I'm not sort of, at least for now, super impressed. All right. One of the things that I found in the last couple of years that I was not aware of is the actual build system is able to give you a view of the actual stuff that's being put in your AOSP, the dependency graph of the different artifacts, and I'll show you how you can actually produce that. It's not something that I've sort of spoken about earlier on. It's not worth doing a full presentation on it because it's really just a short set of commands, but it's quite interesting what you can get out of that. And of course, highlight at least two things in terms of system services that are worth talking about, and then leave you with some closing thoughts. Now the chat is open, so you're free to sort of write stuff in there if you want, or of course if you're watching this at some other deferred time in the future, feel free to leave any comments if you know a bit more about some of the things that I'm gonna cover today. Okay, so just where we're at in terms of a snapshot. So in 10, the big thing that came out of there is Apex, on which Google has doubled down and continues adding stuff from version to version. So assume that there's going to be more and more Apex. At least personally, I'm assuming a lot of Apex stuff is going to continue find its way into the AOSP. In 11, there's quite a few interesting things that were there. GKI, a bit of reworking of the partitions, and also introduction of AIDL for HALs. So starting there, they started transitioning HALs away from Heidel. They've doubled down on this, and it's gathered a pace. And essentially, at this point in time, let's just assume that Heidel is eventually getting sunsetted fairly soon. In 12, there was this cross VM thing, which was the introduction of the Android virtualization framework and all that sort of stuff, which they had some interesting blog about that just recently, and I wanted to actually cover that as part of the one of the things that I wanted to put at the tail end of the presentation here. all right? So let me sort of give you, go back here and sort of just sort of pull up the rough notes that I've taken here as I went through the different versions. So in 12, okay, there's, by the way, I have a whole bunch of scripts that I run to make an analysis of the deltas between two versions. There's a lot of stuff that comes in there out from that, and I'm not going to cover everything. It just makes absolutely no sense. Those are just the things that I sort of caught my eye as I was going through, just to sort of trying to understand as I was going through those things, what is worth my time to investigate more. So if you remember a few versions back, they added compression for push and pull. They added new algorithms for that, sort of just a footnote. Interestingly, there's this new AOSP attach and detach. So presumably for, you know, if you've got a device that's listed in your ADB devices, you can disconnect from that so somebody else can use it, and then you can reattach to that. I've not tried this. Okay, new OS licensing MK, that sort of intrigued me in the beginning, but it seems just a bit of a rearrangement of some stuff that was doing in the main make file that's now sort of found its own separate thing. So one of the things that I've done this time around, unlike the other presentations, is when they added stuff, when I saw them adding stuff into external, I went in there and I looked at exactly what this is. Sometimes there's some intriguing things, others just sort of kind of mix and match with what's already been publicized elsewhere. So I'm going to do a quick run through of the stuff that I found here. So, okay, neural network driver and also an ARM neural network thing. So by the way, one of the things that I found interesting, and let me just pull up my AOSP here just to show you around. Let's just get ourselves a shell there. And by the way, this is my sort of build machine that I've got running a whole bunch of different AOSPs. So let me go for my AOSP 14 here, and let's do the usual run. So this, no, not this guy, but, oh, okay, you can see that I've been experimenting with some of these things. AOSP, that one. All right, let me just pull up Emacs here and show you one of the things that I found interesting in the external directory to figure out what it is that that we're looking at. So for example, this AFL++, which is new in 14. So usually they have these metadata files where they have a description up there, you know, field describing what this package is. So if you're wondering what it is that you're looking at, oftentimes there's a metadata file with this information. Not always. Sometimes when that's missing, then you have a README file like this one, like a readme.md, which hopefully gives you a bit of information about what's going on in there. Oh, let me just take this out of full screen to make it easier. All right. So yeah, so neural network stuff, Basel, Skylib. So essentially, one of the Basel files or projects added is for the Basel integration. BPF tool, XFAT, so that's one of the things that they've added support for in there. Okay, a graphics protocol package for Vulkan stuff, some Golang stuff, and yeah, there's a lot of these additions for, say, Java or Golang or whatever. You'll see some essentially additions from Apache. I think it's down in the 14 this was added. Right, libbpf, more BPF stuff, config files, Chromium Palm injection, liburing. So okay, uring, for those of you not familiar with that, is a new functionality in the kernel for, I mean, new, relatively new. Functionality in the kernel for doing sort of fast operations on the given by user space to the kernel. So essentially, it'll be you know, worth watching what they do with that, if anything. Okay, mobility. This muscle. This one I was actually surprised. I was surprised to see muscle integrated in here because Android uses Bionic. I'm not exactly sure why they use muscle, because it's a C library as well. If you've seen what this is for, or you know, I'd love to hear that. But that one's sort of intriguing to see being added. Okay, nullaway OBEX. This apparently just has moved from framework space, OBEX, OBStack, OpenDice. This is one of the crypto security things. OpenWRT pre-builts. I presume this is for maybe some of the sort of cuttlefish emulation things that they're doing, but I haven't looked sort of too closely at that. More Basel stuff with the Stardock. Okay, the UWB, the ultra-wideband sort of a subsystem here in external, and a few more things there down there that, you know, whatever. So anyway, so this is what's been sort of added, and then you've got essentially what I've seen being removed. A few things, dmessaged. I wasn't sort of too sure exactly what this does. There's not really well commented, but apparently if you do a set prop on this dmessaged start one, it'll start dmessaged, which sort of takes messages from the kernel and then scrubs them off, puts them somewhere. I assume they're trying to sort of just scrub away any sort of information that might be confidential to the user. Okay, there's a whole bunch of AIDL stuff, sort of parts of the HALs that have been AIDL'd, in moving away from Heidel as usual. They did add a few hardware things. So there's this input processor. Apparently this is for sort of dealing with you know, recognizing gestures. This dice thing has been added but removed in 14, so I won't spend a lot of time on this. Of course, in ultra-wideband HAL, as you might expect. And this one actually is sort of weird. I'm not sure like what it is being done with this, the Netlink interceptor. So Netlink is a way to talk to the kernel from user space. And for some reason, this there seems to be an interest in taking that, hijacking it, and sending it somewhere else. I'm not sure what this is about. Again, if you know what this is about, interested to see what you have to say. Multi-tree help in HMM. I don't know where this is invoked actually, because it's not when you do HMM, it's not part of the big list that you see at the top. Like if I do, you know, let me see here, the usual HMM like so. You won't see that up there, but it is here in the list, this multi-tree stuff. Again, not sure what this does, but if you invoke it on its own, this multi-tree help, you get this sort of so let me just do multi-tree lunch help. So in the help, it seems to say that if you do lunch-h, you get this message, which you don't. Because if you do that, you get something else. So I'm not sure exactly how this is getting invoked, or maybe I just don't get it. All right. So this is the lunch stuff that I found. Okay, a few vendor init stuff. All right. In the case of the Heidels, when you log on to the device and you do ls-hal, you'll see that there's a whole bunch of stuff that's been removed. All right. Because essentially it's been moved now to effectively the, let me just actually launch it up and show it to you. So it's been moved to AIDL, and one of the things that's now sort of a bit confusing is, sorry, that's not what I wanted, I'll launch that. One thing that's confusing now is if you do service list no longer just shows you system services. In fact, it's not been showing just system services for a bit. Because one of the things that's been started a long time ago is the moving of a lot of those native daemons that were listening to sockets and div sockets something to AIDL infrastructure. And so those show up as ln service list. And now also if you do service list, as you probably know, come on, that's of course not going to help. It's shell that I'm looking for. So if you do service list and you grep for, say, Android hardware, then you do see a whole bunch of hardware stuff in there because a lot of stuff has been moved from a Heidel to AIDL and now shows up in service list. So whereas in the old days, service list was principally for system services and nothing but, today it's a kind of a mixed bag of system services, native daemons, and also hardware stuff. So it's not my preferred way of looking at things, but hey. Okay, make help, there's this SD nod that was added, and then a whole bunch of things that were apexed under data. You got this under system bin, a few more additions. The one thing that I sort of noticed in there that caught my eye is this thing called service dispatcher. Let me show you this to you. So service dispatcher. So these, let me just make it bigger here. So this seems to say that is going to essentially open a socket and proxy the stuff that comes on the socket to system service. It's kind of like, okay, what's the use of that? And also, by the way, if you read the actual online help here, it's like telling you that it is for it's on debug builds only. So not clear exactly what the use case for this is, you know, in practice, right? Okay, ta-da! So in 13 they dropped GDB server. That was not sort of unexpected. The Android team's been moving to LLDB and LLVM and all that sort of stuff for a while, so I did not see this as being too unexpected. And of course, if you want to see, you know, what's been sort of moved up into what's been added to system services, some of the stuff is, as I said, covered in separate documentation about additions they've made. Okay. So that's what I found in 13. Let me sort of drag up what I found in 14, just from 13 to 14. So we start seeing a bit more Bazel stuff, okay? I found two sort of interesting documents here that sort of lay out, you know, the actual, let me just try to highlight this and actually copy that somewhere and open it up here. So FYI, if you've not, no, please go away. There we go. So essentially here, this is the description of the build system that covers all the different generations of it to an extent. So what does CATI do for the MK files, the blueprint files, which are taken care of by Sung, and is effectively sort of explaining here, you know, what Bazel is doing on its side here, managing, you know, mapping to Bazel concepts, essentially explaining to you how this maps down to Bazel. So if you're trying to sort of follow what's going on here, you know, we started off earlier on up until 7 with GNU Make, and GNU Make was showing its limitations. All right, it's Android as an package, you know, as an AOSP, the whole thing is complicated to deal with, and so they were stretching Make to sort of its limits. And one of the biggest drawbacks with GNU Make at the time was that every time you type Make, it will actually go around including all the Android MKs into this single build file and then run through that single build file. And so every time you typed a new Make, it's sort of like, it would sort of take 5 minutes to just include all these Android MKs before it actually started doing anything. You know, at the time I had an interesting conversation with the person that was maintaining this, and I said, hey, could we just cache this stuff around? And that seemed to be an intent of possibly looking at that, but then essentially it moved on to other folks that took care of it, and then they introduced Ninja. So the way Ninja works, and you can sort of see it in the beginning when it starts, it sort of looks around for all the MKs and generates Ninja files out of those, or BPs of course as well. And so long as you don't change any of those, then the next time you type Make, it's sort of instantaneous. So like this caching thing has been sort of taken care of. And now, of course, they're moving on from Ninja to Bazel, which will also take a couple of versions for before it settles down. And if you look at the documentation, even right now in 14, they tell you this is still a work in progress. So, from my perspective, one of the things that I'll be, you know, looking for to probably sit down and take a closer look at in 15 when that comes out is what are they doing there with Bazel? Because for right now, it's there. Yes, they're using it in some parts, but the sort of like the big chunk is still sort of pending down the street. Okay, so that's for Bazel. All right, more external stuff being added here. So I'm going to skip through the ones that aren't really sort of major, at least in my eye. So okay, FL++, Java libraries, Apache, some Bazel stuff, Cronet, Gmail Smalley, decompiler, disassembler, Chrome gestures. Okay, this one is surprising. Okay, that really caught my eye. This libtrace event and libtracefs, as well as actually tracecmd itself. So these are the packages that Stephen Rosted maintains in the kernel for tracing. They're either GPL or LGPL, so I was kind of a bit surprised to see them in here. Actually, sort of, I looked for who includes trace CMD as a build target in the AOSP, and nobody does. So I'm not sure why that's there. It's intriguing. Definitely great, because the atrace command line tool that was in Android, or is in Android, definitely doesn't compare with what trace CMD is capable of doing. And so I'm eagerly awaiting to see where this gets to be used, if anywhere. All right, but that being said, this is not the first time I see that in an AOSP, just not Google's AOSP. I've seen trace CMD being included a long time ago in some vendor BSPs, but that was at the behest, I guess, or the initiative of that vendor. And I looked back actually at when it was integrated on android.googlesource.com, and it seems to have been integrated around in some branches of 13, by the way, but not, for example, 13 GSI. So I usually use GSI as sort of like the gold standard for the stuff that I do, and in 13 GSI it's not there, but it is in 14. It is in some 13 branches, and then in 14 GSI. So that's interesting. All right. OpenThread, implementation of the thread networking protocol. Also other thread stuff here with this router stuff. Roboelectric. Yeah. Okay. So under AOSP sort of a system directory, there's this new directory called keymint, which seems to be some sort of derivative of, I guess, Keymaster and whatever else, went with that. I have not dug into that too much, but next time I revisit the security stuff, I'll be interested to take a look at the keymint things. Okay, of course, more additions in the, more movement in the AIDL side, and new HALs. So those are always interesting to see. So in this case, for example, they have this interface for in-vehicle network, and this is essentially for the fact that you might have multiple Android devices running there, or multiple zones, and so they seem to have a HAL for this. And a remote access interface, I presume this is for remote key entry or something of that kind, but I may be guessing wrong here. So again, if you've played around with that, I would love to see your comments on this. Okay, the air provisioning certificates for the essentially this is for remote provisioning, I guess, and so on. They have a new staging directory that I noticed where they seem to be putting HALs that are not yet ready, I assume, things that are in development. And then there's this TV HDMI thing that's been added, some removals there and so on. Okay, HMM gets a few greps, nothing really too impressive here. And then this multi-tree thing that intrigues me, that I have not yet figured out what the purpose of it actually is. Okay, now if you do an LS HAL today, they really strip this down. Essentially, a lot of this stuff is gone now. So LS HAL, which was for listing the HALs, the HIDLs that were active, used to print way much more stuff than this, and it's now been really sort of trimmed down to just the bare essentials. Most of the stuff now, as you can probably imagine, has moved to service list. Grep, say, android.hardware. And let's just count those up. So we've now got about 74 entries that have moved to the AIDL interface instead of HIDL. Okay. Right, there's a make sync for doing a make, but without actually sort of building the images. So this is useful for ADB sync if you've used that. One interesting thing to look at is the mount point differences. So you'll notice here that in 13, a lot of the file systems are mounted over ext4, and now in 14, that is all moved on to F2FS or AeroFS. Okay, so it seems that ext4 usage in AOSP is pretty much on its way up. Not surprising. This is not something that was unknown. All right. Okay, a few more apexes. Okay, so by and far, the thing that caught most of my attention was the addition of VI inside toy box. Or it's not been new. I actually looked at back, like, wait a second, when did VI show up on the command line in Android? And so it actually was in the code since 8.x, at least. That's as far as I went to look for it. It's actually been compiled in Toybox from 11, but the symlink wasn't there, all right? So today, actually, if you do a VI, foobar txt, ta-da, I can start typing my file here, and I can sort of quit, and I'm not sure this is going to do right, so I can't fight foobar, of course. So let's quit and don't write anything. This was so like the civilization catches up with Android moment for me, at least in terms of VI appearing on the Android shell. Another thing that I found interesting in there is this record binder. I was like, what the heck's that? What does that do? How does this work? And sort of actually this one I took a deep dive and I went to look at the code to see exactly what this is actually doing. And you can try that here. So record binder. Okay, so essentially what you can do is you can listen to a binder communication with a service. So I could do something like record binder, and I want to listen for window. All right, essentially the window manager. It's now listening to the window manager. Let me go actually and do a few things here. So localhost this. Yeah, please show this to me, and let's go just, I don't know, start the gallery application. Okay, so you can see here it actually is now able to watch the actual requests that were made to the window manager. And what is interesting, let me sort of show that back to you up there. So record, no, that's not, go back. Just record binder. Okay, so you can actually replay the stuff. So you can actually sort of record an actual set of transactions and replay them back to whatever system service you were actually recording. And I was actually sort of intrigued about how this works. So yeah, okay, so start activity and start listening to activity, stop listening to it, and then essentially you can inspect that stuff. Okay, so where was that? Yeah, so one of the things that it's got is it says, no analyzer, for this interface. And I was like, okay, what's an analyzer? How does that work? Do they have any inside? And it appears they don't really have any analyzers that are sort of coded up, or I haven't seen them, all right? So let me actually show this to you in the code. So if you go here, where's that again? Sorry, that's not what I want. I want this. So going all the way up in here into system, tools, AIDL, and then there's, where's that again? Analyzer, and then in there's the analyzer CPP, okay? And it's a pretty empty file. There's really no sort of analyzing being done here. I don't know if this is just a placeholder for future editions or it's just a placeholder for people to actually start doing stuff in there if they want to. It's not clear, all right? So yeah, so there is a list command in the sources, but since there's no analyzer, the list command just doesn't return anything. So, I'm not sure. Okay, and the way this works essentially is that this is a transaction that's done essentially on the receiving end of this. So we say start recording, and then if the recording is on, then we actually sort of start writing this in. On the transact, yeah, this is unlikely, but if there is actually recording on, then you actually do write dump to the file. And yeah, they have an actual sort of a map of the transactions, how they're written down and all that sort of stuff. So if you were interested in the format, the code is there to show you how that's sort of taken care of. This is, however, all done in user space. And it involves the binder. So it's not a kernel tracing mechanism. You can, if you want to really have a trusted source of the information, you can probably go to the kernel and get the same information. But still, sort of interesting to see what they've been doing around that. And of course, a whole bunch of system services being added here. One of the things that were sort of intriguing me here is this wearable sensing, and I went to look at the code. This does not have to do anything with Android Wear, so if you see that system service, it's different. Is the record binder have any relation to trace IPC command, AM trace IPC command? I have not looked at that. That's a good question, Ahmed. I'd have to look that up. I've not done any sort of correlation between the two to see if there's any relation there, but good question, all right? Okay, so that's for essentially the additions I've seen in 14, some statistics for you, and really this is sort of like that thing that usually is sort of always concerning me, is how much time is it going to take to build this? So I went back and sort of did a comparison back to all the way to 11. This is the same machine I described in other sort of presentations. This is a Threadripper, AMD Threadripper with a whole bunch of RAM. And it usually does a fairly good job at building the AOSP. I'm not seeing any sort of too big a variation there in terms of build times for 14 GSI. So that's not too bad of a thing. All right. Right, Linux Plumbers. So, okay, this is what Linux Plumbers, for those of you not familiar with it, is an event that takes place once a year. It is organized usually with, you know, a refereed track with formal presentations, and then a set of micro conferences on different topics, stuff like, you know, file systems in real time and tracing and whatnot. And I've been running the Android Micro Conference since about 2012, and we've had, over the years, of course, tremendous good results with seeing participation from the Android team and the actual kernel team and Linux community in general, where sort of like a rendezvous point for people to come in and hash out sort of discussion topics that are, you know, need to be ironed out. All right. So there's a bunch of presentations that took place at Plumbers that relate either close or far to Android that I thought would be interesting to cover. I am not going to do justice to any of these presentations. I'm covering like 20 presentations, and really quickly here in a sort of rapid fire sort of sequence, as I'll show you. I mean this sort of quick run through as an enticement to have you go look at the actual presentations, all right? Because they're really well presented. There's really interesting stuff, and if you're working in that specific area of Android, then you'll definitely get some bleeding edge info from that. So let me just sort of go back to one of my shells here, if I can find one that's appropriate. Apparently not. Okay, so let's just do this. Let's change this to a more convenient format. Let's go here to, all right, this is on my desktop, I believe. Let's go here to, I can't remember where I put that. This, right. Okay, and now let's go to LPC. All right, and let me just go ahead and open it up. I did just a whole bunch of screenshots there. So I'm just going to go through those things. So, okay, this is a presentation by Qasim. Oh, sorry, that's not what I want. I don't want you to sort of go through those automatically. Qasim's been involved in a lot of, you know, Android and Linux stuff over the years. Definitely a very knowledgeable person in the field. And essentially, Qasim goes over and one thing, by the way, sort of as a parenthesis, I loved it that he got the first spot at the referee track because the topic that he talks about, which is boot time, and how this how it's done usually in Linux and how it's done in automotive, is certainly something that I think people that we work with in the automotive business will appreciate. At least from my perspective, it was interesting to see this being brought to the fore as an important topic to discuss. And so one of the things he did throughout the presentation is essentially explain the difference essentially between you know, how it's done usually in Linux and how in the automotive business things need to be done to make them sort of realistically working. So I sort of stole this specific slide from his presentation because he shows out that essentially in the normal Linux world, you boot the thing linearly until you get everything up and running, and in the automotive business, it's like, no, you can't do that because you're not going to actually get the decent performances that you actually need, so you're going to have other stuff on the side that's going to start in parallel. And then the question is, how do you actually mesh all that together? So this was a bunch of interesting discussions around that. Let me see here. So I think 32 gigs of RAM, no longer enough to build 13, 14, 13. My system froze when Sung started. Yes, Ahmed, this is something that honestly I have seen some instances of, especially if you've got other stuff opened. Like if you've got Android Studio open and you try to do the build, it doesn't like it. So Mathieu, the RAM amount is depending on the number of threads you use. True. Actually, this is an interesting rule of thumb there. 2 gigs per thread. I like that. Based on the, this is how you, okay. Yeah, that's not a bad recommendation there. Again, rules of thumb, but worth looking at. So anyway, back to this. Do look at Qasim's presentation. Very interesting. Okay, so this is Len Brown's presentation about suspend resume. Okay, part of the referee track. Totally not specific to Android, but interesting nonetheless. Because essentially one of the questions he was asking the crowd is, hey, is anybody actually interested in hibernation to disk? Is this like still a topic? And I was like, yes. And there were a couple of other folks that had their own sort of things. So for example, I think he was mentioning that, okay, yeah, the encryption thing prompted a response from one of the Chrome guys, I think, if I recall correctly, that stated that in their case, they do actually encrypt the hibernated stuff or something of that sort, if my memory serves me right. Again, I'm not going to do justice to any of these things, so do look at the presentations. But there was another person, I think it was David Woodhouse, that mentioned that definitely hibernation images would be useful for things like VMs in the cloud. And you know, my take, which was my comment in the presentation, is yes, this would be interesting to Android, being able to sort of restore from hibernation instead of like doing a clean boot every single time. That could be interesting in some use cases. Right, and there's continued discussion there for the RAM in the chat if you want to follow this. Okay, this is the presentation for the port of binder or rewrite of binder to Rust, and I would dare to say this slide here is probably going to become legend at some point, because on the left hand side what you've got is the sort of error handling or exception handling at the end of the binder driver in C, and essentially how it's done in Rust. And this, which prompted a good clap from the audience there, because if you wanted to show the usefulness of Rust, that's probably a good way to actually show that. And this is interesting as well, because these are the sort of the performance results of the Rust written binder driver versus the C written binder driver, and you can see sort of like the performances are pretty close. So they're not. There is already a push for this on the actual sort of the list. So I will be interested to see where this goes. My bet is probably this is eventually going to replace the binder driver in C at some point in the future, TBD, and we'll probably set an example for other drivers as well. Again, speculation on my part. We'll see what actually happens in the future. But definitely a good presentation as well to recommend. This was from the presentation by John Stoltz on proxy execution. John is definitely smarter person than me, so I would definitely encourage you to read, to watch his presentation, because I'm not going to do it justice in any way, shape, or form. But the problem statement is well explained in this slide. Essentially, the issue that we have is we want to provide foreground processes with sort of the performance the user needs for that process to run, and that's a challenge in Android. There's a bunch of hacks that are attempted to make this happen, and so proxy execution is the idea of trying to solve that, or at least one of the solutions to this problem. And that's where I'll let you sort of watch John's explanation of, because I won't be able to do justice to it. But essentially, and I had some numbers, or intended to have some numbers, and apparently I sort of skipped those numbers. I'm sorry, I had another slide that I took from there that showed the outliers and not outliers of this, and for whatever reason I dropped it. Anyway, with the work that John was doing, he was showing a graph that the proxy execution does seem to actually solve a lot of the outliers in the scheduling stuff. Okay, this was a presentation by John Moon so actually this is the first of the presentations as part of Linux Plumbers Android Micro Conference sort of a track, and this was essentially a presentation on the integration of the DDK into the workflow that Qualcomm has. So essentially this is the stuff before the migration to it, and if I can get my mouse to work, post-migration, as you can see, sort of like they're moving to all this Bazel stuff that you can see there, with the integration of the different files, including the build Bazel files and so on and so forth. And so what's interesting in there is one of his last slides is the needing to learn a new build system. And I was actually talking to John later on. He said he spent some time actually, he had found one presentation, apparently, and I'm not sure if I'm doing justice to what he explained, but apparently he found a good presentation on YouTube about Bazel and used that to sort of school himself into how to work with this. So definitely that is, one of the things that a lot of the people working at the platform level will sort of have to upskill themselves into, which is sort of mastering a new build system, given that Google's moving sort of away from of course, good to make a long time ago, but now moving away from Ninja to Bazel. So the next presentation was essentially the DDK presentation by Matthias Manik, who's actually the maintainer of that at Google. So essentially showing the state of things as they are in the DDK today. By the way, for those, I'm sort of mentioning DDK, sort of assuming people understand what this is, but essentially in Android GKI infrastructure, generic kernel image, you want to build a driver against GKI. Then the recipe is to use DDK, the driver development kit, part of GKI. So that's the context here that this covers. And so showing an example on the right-hand side of an actual build Bazel file for building two sort of modules, and essentially moving up to 15. One of the really interesting things is that you're now going to be able to build modules straight against the artifacts that are published by Google essentially at ci.android.com. So in other words, you get a GKI kernel, all right, and you can build your module against that binary download that you got without having to get the sources necessarily. That was one thing that even at the beginning or the launch of GKI was always a question. In fact, I think it was part of might have been even part of one of the emails I sent Matthias in the very beginning when I sort of looked at this stuff. So the question was always, how do I build a module against your thing? Right, that's super cool, but hey, and it appears that with moving forward, we're going to be able to just grab a GKI kernel from Google and just sort of like, build the module against that without necessarily having to download the sources. And that's actually sort of very interesting, because that means essentially that you can continuously rebuild your modules against new GKIs and publish them without necessarily having to depend on the ABI compatibility that GKI gives us, right? So the idea of GKI is if I build my module against version X and GKI continues evolving, I mean, within that branch, of course, then I can download the new GKIs and run my module against those without changing it. But this ABI compatibility apparently turns into an API compatibility that's sort of firm enough that I can just go on rebuilding those modules and then ship new modules for every version that comes out. So that's for the DDK stuff. Okay, the BPF talk. Essentially, the idea there was Android has special requirements with regards to what it can permit and can't permit. So the general infrastructure that Linux has for BPF handling may not fit what Android needs. And so the presentation there laid out essentially the way things are done in Linux, which is what you see here. So essentially you got the BPF program that's being sort of changed into some sort of bytecode, loaded into the kernel with the verifier, and this attaches the stuff to the kernel. And okay, not sufficient enough for Android, so then there was a sort of bunch of different explanations about the challenges that need to be taken care of here, and sort of BPF loader today with Android, how it works, which sort of loads them up in a single shot. You can see some of those, I think, under system etc something that are being loaded up. But the idea here is to actually add a sort of verifier or sort of an access control point. You can see here at the complete bottom right-hand side here, where you then have sort of an ACL, of who can load what, I guess, and the idea was to see whether this is an approach that is of interest to the Linux community. So definitely, if that's an area of interest on your side, I'd recommend looking at Neil's presentation there. Okay, the binary buffer presentation by Carlos is fairly sort of nitty-gritty. You really have to sort of be aware of the difficulties and challenges of managing buffers at the kernel space to appreciate the work that's being done there. So if that's your cup of tea, definitely look at Carlos's presentation. And so what he's explaining is that there's different problems that are due to contention on these buffers and stuff, and the Android team is looking for solutions for this. And so there are essentially sort of proposals to do that, and he came in to present us what work was being done there. The next presentation by Betty Zhu was sort of like addressing eBPF objects are under system etc BPF. That's correct, yes. Thank you for that, Ahmed. So the presentation by Betty was about essentially the challenges that Google has for testing kernels across different versions of the platform. As you can see, there's a lot of kernels to be tested. And the question is, how do you actually take care of that? And so, of course, this is CI stuff, continuous integration stuff. So have a look at the actual presentation if this is up your alley. But essentially, the idea there is to do tests at different opportunities to catch any problems along the way. Then the next presentation was by Sarvana regarding the suspend and resume performance. The question is, of course, when you press the power button on the phone, how quickly does this thing come up? And sort of he laid out essentially all the difficulties that there are, the issues that exist essentially today with the taking care of different parts that sort of slow down this process. And the presentation was sort of like abruptly cut off at the end with some of the discussions, but the whole point of the Android micro conference, of course, is to put people in touch to an extent so that they can sort of go into the hallway track, as they call it, and hash out some of these topics further down the road. All right, the next presentation was about RISC-V support in Android. So definitely there is a clear, path there of desire of adoption. So I would expect that we're going to start seeing, more and more of these RISC-V devices running Android. And of course, this was just a state of where things are. And of course, if you're interested in that, have a look at Curtis's presentation on this topic. Third-party hypervisor. So Qualcomm has a hypervisor that they use called Gunya, which essentially sort of goes or integrates into effectively what Google's got for Android virtualization framework. So instead of using Google's thing, they use the Gunya thing, and essentially the explanation is how they're doing this stuff. So one of the things actually about AVF, let me just open a parenthesis about that, had evaded my understanding for a while, and I'm not sure if I had mentioned that in the last video, was how the heck does the actual, how do we protect the guest protected instances from the host, right? Because the host has got the memory and hands them off to actual guests. And in some discussion on LinkedIn, it was explained to me that what happens is once the pages are handed off to the guest, they're essentially kind of taken away from the host, and therefore if the host tries to access them, the PKVM sort of panics and then shuts the whole machine down. So effectively, the Linux is giving away some pages, and then they no longer belong to or memory regions, and they no longer belong to it. They belong to whoever's the guest. And then if Linux tries to touch those pages again or memory sections again, then it reboots or panics at that point in time. Okay. So that's the Qualcomm integration into AVF. Okay, porting. Okay, this was a presentation by Leo Yan from Lenaro about the porting of automotive over or the automotive emulator on top of. Actually, the thing was entitled. The presentation was porting automotive on Zen. So it was like, okay, so. My question after this presentation is, why do we need that? Who needs this? And Mathieu Paulier from Lenaro sort of explained that this is just to sort of show that it can be done, because nobody's actually going to use Zen in automotive, but it does show that you can take a tier 1 RTOS or something like that and then use that on top of it, or some tier 1 hypervisor. That is sort of accepted. So that's interesting as an approach. But at least for me, when I watched that presentation the first time around, it was not clear what is the intended goal of it. Okay, Pixel 6 support and sort of trying to strive for the aim of getting kernel mainline of running Android devices or Android sort of on devices sort of out of the box. So if that's one of the things that you're interested in, then have a look at it. There's always been a delta in my mind, at least, but the Lenaro folks have been doing demos of this for a while, and there seems to be a desire for using this as a reference sort of platform for all sorts of things, for development and so on and so forth. Okay, this is a presentation by Kais Youssef, who was asking the question, can you run essentially Android without the vendor hooks? And so again, just a bit of context here. The generic kernel image from Google, the GKI stuff, is prefab by Google, so you're not at the liberty of actually changing the build configuration to add what you want or modify the code. And so to provide a way for vendors to sort of kind of go around the limitations, Google added this thing called vendor hooks. And the idea is you can use those hooks to hijack whatever's going on and do something else. So the question is, can you run without those? And sort of Kais explains what you would sort of see as an impact if you didn't have them, and then sort of goes in, and that's where the part I'm not going to cover is essentially explains what does this really mean, why is it that we can't sort of get rid of those things, and so definitely if scheduling is one of the things that you're interested in, that will do a good presentation there for you to watch. Okay, 16K pages. So this one actually was covered, overflowed actually from here to the BOF afterwards, to the actual Android BOF that took place 2 days later, I think, or a day later, I can't remember anymore. So anyway, this was definitely, above my head in terms of complexity. Memory management has never been sort of a thing that I've really truly loved in terms of operating system concepts. But if that is where you have your fun, then have a look at this. Essentially, the idea is to use 16K pages instead of 4K pages, which does show some improvements, but then it sort of breaks a whole bunch of other things because everybody assumes 4K pages, and so the question is, how do you sort of mesh those two things sort of together? Okay, dev boards. I'm always eager to hear about those things, and Sumit Simwal from Lenaro did a great talk about that. And there was a bunch of other sort of presentations that, as you can see here, he refers to during his own presentation. So it's always good to see development boards that are able to run AOSP. Many of those have been sort of maintained by Lenaro within AOSP. So he definitely knows his kung fu there when he's speaking of this topic. So that, I think, is pretty much what I've got here for the coverage of the stuff at LPC that was worth sort of talking about. Okay, so again, I'm not doing justice to any of these presentations, and I apologize for anybody who did a presentation if I massacred your intent or whatever you did cover. But definitely, at least I think if you're watching this video at any point in time and any of those topics sort of interest you, then have a look at the actual original presentations. All the people that I sort of talked about here did brilliant work that is worth your attention. Okay, let me switch over to the Android Studio for platform, if you're not familiar with that. So Android Studio for platform. Okay, so essentially this is Android Studio, as you probably know, is the development environment for app developers, and there's now apparently a version for platform developers. Like, oh, cool. Let's go take a look at that. And so I did go download that and install it. And let me show you also a bit of screenshotting here that I did with that. So AOSP, this. Okay, so it starts off with a wizard like that, and essentially you click on this import AOSP project that you got there. Asks you where the sources are, and I'm like, okay, cool. This is going to understand my sources. And so just to give you an idea here, my reference point is I'm used to using Android Studio, the original one, where I go into my OSP, I do a make IDE gen, and then development tools IDE gen.sh, whatever it is. It generates an IPR file. I open this up in Studio, and I have Studio sort of munch on this. So my expectation was sort of like, this is going to do that thing for me without me having to do anything. Apparently not. So anyway, you load this up in this wizard. Now, if you watch the video, which I did not, I was like eager, this has got to be easy. Let me just go download the thing and run. So I didn't watch the video first. It turns out you actually sort of provide these module paths, and I'll explain to you what this is for in a second. So anyway, my next thing is like, okay, so I did it, I loaded up, you get the usual Studio thing, and you can see here it's generating some artifact on the bottom, and it says indexing JDK, and then, I got myself this environment. I was like, okay. And I started proceeding on to actually looking on the left-hand side there for my projects and my code. I was like, wait, where's my code? There's nothing in there, right? And sort of naively, I went into the module and I said, okay, well, how about you add, so you go into this project structure and modules, and I said, okay, let's just add the entire AOSP. It did not like that. So it went onto this sort of screen here for quite a bit, without actually loading anything up. As far as I know, AOSP is just for IDE Gen tool to integrate into. So essentially, and then I was like, after I'd done this and it didn't work, I was like, okay, let me just go watch the video. And so apparently the intent is for you to actually go and load modules individually. So there's like parts of the AOSP, but the video did not hint at actually being able to load the entire AOSP, which sort of like seems to indicate there's a different sort of usage model here, and I'm not clear exactly that I understand their usage model. At least maybe it makes sense if you're working on specific parts of the AOSP at any given point in time, but I'm sort of like everywhere all the time, so I want to load the entire AOSP in there, and that doesn't seem to be sort of an option. Or again, maybe I'm just missing something completely, or this is brand new or whatever. That being said, I don't mean to say that from my perspective this is not worth your attention. Rather, it's more like, okay, this is seems to be a work in progress. It'll be interesting to see over time where this actually sort of goes. And if you're listening on this and working on that tool, my invitation would be for you to actually allow us to just load the entire AOSP up in some way, shape, or form in there. Okay? All right. The more interesting use would be to the whole environment compilation and fastboot integration, which is not supported as far as I know. Correct. I mean, the whole thing, I mean, it would be interesting for this tool to be like a one-stop shop. Here's an AOSP. click on build, shoot it to the device, bingo, right? Is only being able to get access to the AOSP external group. Oh, I've not tried that, honestly. Yeah, there's a mailing list. Yeah, there's a mailing list, and I'm not sure how you subscribe to that. But I mean, I guess you click on it and open my email client, so I assumed that I should sort of send some subscription notice. Or maybe it's just one of the Google groups, by the way, but I've not tried that. So I've not actually tried to sign up for this, but if somebody knows, then definitely point it out to in the chat or in the comments later on when you get the, I got accepted, but I get a 404 in Google groups. Oh, sorry. Okay, well, I'm sorry, I don't know what's going on with that. Okay, building a product graph. So one of the things that I actually sort of have always struggled with explaining AOSP to people is how do you actually build a description of a product? So essentially, for those of you familiar with this stuff, if you go to the sources and build target product, then you've got all these different MK files, each of which is sort of like a snippet of a recipe, and you stitch them all together, and voila, you get yourself this list of packages that you are going to build. And if you're not familiar with this, you can do a get build var of product packages, and it will list you the packages that are actually configured for the actual config that you got right now. And in this case, for cuttlefish, it says that it's got about 930 some packages that it chose. And of course, you know, the sort of like usual thing to ask yourself is, well, 933 of how many? Well, then you can do something like, you know, go dear Android BP, and it finds almost 10,000 of those MKs, and then you can do a basil, you know, basil whatever, and you're going to find, sorry, basil build, stuff like that. What am I doing? Sorry. Clear. All right. Anyway, so you do the same thing, and you sort of end up with like thousands and thousands of files to choose from. And the question is, how do we come to a recipe that makes any sense? And so what you'll find is under the devices directory, you have essentially for any of the products that you got, in this case, this is cuttlefish, you know, they'll sort of latch on to one of those build MK files, and it will go and include a whole bunch of other things. And I've always wondered, sort of, is there a way to look at those stuff, right? And I was actually talking to some people in one of my classes, and they said, you know, there's an actual tool that does that. And I'm like, what are you talking about? So there's actually a command that will actually build you a view of what you got. So it's called make product graph. All right, you do something like that. All right. And what it will do is it will run in there and sort of generate a file that you can then convert into a PDF. And let me show what the PDF looks like. So let's do evens out product PDF. And so this is the complete view of all the files that are actually included to build the actual cuttlefish target. So if you go down to the complete bottom there, this is essentially my cuttlefish. All right, and it's including this build make target product core 64-bit. Or on the other side here, it's got this build AOSP product, which itself includes this other thing, which itself includes other things, and you can sort of reroute the whole thing all the way up to the top. And the first time I discovered it, I was like, oh my God, I can't believe I've lived so long without this. So definitely something that is, well, if not entertaining, at least sort of insightful as to show you what your sort of AOSP end result is deriving from in terms of all the pieces that are being included in other parts of the AOSP. All right. So again, if you're like sort of taking notes and like, what did he type again? Okay. So the command is make product dash graph. All right, like you can see here, and it will generate you again this file that you can then convert. It's a dot file. Honestly, I had never used the dot tool before this, but anyway, so you can use that to convert it to a PDF and actually look at the graph that you just saw over here. Okay, a few system services that I actually wanted to cover. Okay, so let me actually do a quick Google here. So AVF Android blog post. So yes, I think this is what I'm looking for. So Google published this blog post not too long ago, actually a week or two ago, explaining essentially how you can use the AVF stuff, and from my perspective, this has been long in the coming, so it's not new. But what is interesting is that it's now being sort of promoted out to the public in general. So several years down the road, after having started this work, it seems to now be actually published for everybody to look at. And sort of they talk to you here about the system services that are being sort of involved, this virtual machine manager, virtualization service, and so on and so forth. So again, one of the things that I sort of always wondered is how the heck do we, when they say here protected KVM, is how is it actually protected? Well, it's protected because the kernel that is actually handing off the memory here is now no longer having access to this memory, and if it did try to, then KVM would panic, and so that's the protection that you got there with this. Is there a way to generate this in a different way so that we can see differences with a simple diff? I'm not sure I understand your question, Matthew. You mean like diffs between two product graphs, or diffs between the content of the product graphs? Maybe that's sort of what I'm missing there from the question. I'll let you sort of, because it's deferred, so I'll let you sort of take the time to answer that, and I'll continue and I'll catch up your answer, and we'll see. Okay, so that's for this one here, and then there is the Android AI Gemini blog post. This is the leverage Gemini in your new foundation for AI. I think this is the one I saw earlier. So essentially, yeah. So there's this AI core system service apparently, or something like that, is going to, yeah, there we go, AI core, new system service for on-device foundation models. So apparently they have a system service that deals with this AI. Yeah, okay, so just a sort of parenthesis regarding the diff. Yeah, so diff between two product graphs. I don't know that that exists, Mathieu, but then again, I could be surprised. I did not know about this product graph, and I sort of learned something new by when that was sort of mentioned to me. So maybe this does exist. I just don't know about it. Okay. So this is another sort of system service to sort of worth investigating, I guess. Even though, you know, to an extent, this seems to be sort of tailor-made for Gemini. But it'll be interesting to see if there's some sort of way to sort of extend that to other engines, if that is something that you're interested in. What else did I have here on my list that I want to cover with you here? Yeah, that's pretty much it, I think. In terms of closing thoughts, so going forward, or maybe sort of just to sum up, the things that sort of caught my attention most out of looking at what's been done. I mean, okay, a couple of high-level remarks. 13 and 14, from my perspective, were organic in their evolution. There was nothing revolutionary, definitely not something in the scale of, say, Treble or GKI in there, okay? So cross-VM is something that, or the AVF stuff has been sort of, was launched even before that. So I did mention, I think, in my AOSP 12 presentation. So this is just a continuation of it. I'm not seeing anything radical in the internals that is going to be deeply perturbing, other than, of course, the introduction of Bazel. So that would be like the next item I would want to watch. And if you're looking for upskilling yourself into something new, then have a look at Bazel. That will probably be an area where you would want to investigate or spend a bit of time. In terms of the changes at the AOSP level, again, I think the two things that sort of most surprised me, I guess, is as naive as it is VI. It's kind of like, okay, wait, there's an editor now on the command line and Android. And then trace CMD, all that stuff is like, wait, what? Why is that in there? I'm still sort of trying to figure that part out. Yeah, so that pretty much is it from my side. I think I've covered pretty much everything that I've seen. If you have any additional questions, please feel free to post that in the chat. Happy to pick those up as they continue coming, and at some point I'm just going to shut this down once we run out. Do you have any thoughts about Harmony OS with a microkernel architecture? The performance is supposed to be better. Okay, no, I'm not familiar enough with that to be able to comment. the general sort of sense that I've always had with other kernels or other architectures has always been that, yes, okay, but Linux didn't get where it did by just essentially being nice looking or having the most blazing fast things, but they've eventually caught up to many of those things once they were shown as being a problem. So if there was something that showed better performance, I'm not sure that it would be impossible for Linux to catch up. So I've not looked at that specifically, but that's just like generally what sort of comes to mind off the top of my head. All right, so once again, a general call there to actually look at the, if internals is of interest to you for Android, have a look at all the presentations from, are we supposed to expect a Bazel building in Android 14? I think it is actually being used. I mean, I've seen it sort of spill out stuff in the output there when you do type one of the makes at some point. You know, early on or later on, it eventually tells you that it's doing some Bazel stuff. So the issue that you will see though is if you take a look at, say, build Bazel or Bazel, come on, what am I doing wrong here? There we go, Bazel. If I type it properly, README here is experimental. Okay, so that's sort of making me hold off on sort of spending too much time on it, because it just tells me that there, even if it is being used, then there's still some stuff that needs to be ironed out before we can sort of assume that what's there is going to, you know, continue living off as in its current state. That being said, and just to sort of as a sort of counter example, or of the fact that I may not want to wait too long, is if you go to hardware interfaces, it's automotive, and there's a README file in there that still says that the HALs are not yet frozen. Yet this is shipping. So anyway, I'm not sure if the README file is out of date or what else, but that will be interesting to watch as well. All right. Okay. Well, what about RPC binder? I heard that the infrastructure is there, but there is no implementation that really uses it. Okay. Correct me if I'm wrong. This is the binder stuff for AVF. Is that right? If I'm not mistaken, I think that's what it is. And I'm just waiting for the response there. Yeah. So this too is actually there was a presentation a year and a half ago, 2 years ago, can't remember, by the Android team at one of the Google sort of live streams, and one of the questions was how do you actually sort of transfer file descriptors to AVF instances. That also is stuff that I guess will be documented in terms of, you know, proof in the pudding by actual examples as the adoption of AVF increases. What was interesting though, actually sort of forgot, in the AVF blog post, I sort of jumped over it. Where's that again? So yeah. So one of the things that they actually sort of mentioned several times here is that they're actually trying to sell you off of Trust Zone. So there's several instances where they actually explicitly mention Trust Zone. You know, have an alternative to Trust Zone, and then later on there's another sort of thing more portable than Trust Zone, and sort of like they're like promoting the benefits of AVF versus Trust Zone. And this is in line with presentations that had been done years ago, where essentially at the start of this, the people who were working on it said, look, there are these problems that we see with Trust Zone, and we're trying to solve those problems. So that will be interesting to watch. And given that this is being promoted in that angle, I would assume, just sort of to sort of cue in back to the or loop back to the question that was being asked, I would expect to see some of these things to be explicited as we go forward. So yeah, the MT is the memory blah, 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 which I can never remember. So they have a new command there called MT control. Sorry, looking for MTE control. Yeah, our memory tagging. So if that's of interest, Google has essentially for Android BP. Okay, so let me address the thing, the MTE thing first. So the ARM memory tagging stuff, Google has a page on source.network.com about that, and there's a new command called MTE control on the command line. I haven't played with that. But that's as far as I've taken a look at this, and I'm by no means an expert in MTE in any way whatsoever, right? Should we, regarding Bazel, should we prepare ourselves for Android BP MK replacement? It feels like they're going in that direction. If the transition from MK to BP is any indication, that's going to be taking several years. But certainly in case of the kernel, for example, it's been a clean-cut deal. I mean, they've gone to Bazel for the kernel builds. And the AOSP may be a slower moving boat because there's a lot of people involved, but that too seems to be going in that direction. And definitely, like for me, to speak for myself, I will be sort of taking, I'll be taking some time to school myself into Bazel myself, to make sure that I'm ready to whatever changes they eventually make in the build system with that. Although again, if you actually also take a look at the evolution of Bazel's use in kernel, it has been essentially taking a few iterations for them to get to have all the features they want to have. So that might also be the case of what happens with Bazel. From my experience, there is no real way to directly talk to Bazel in AOSP builds, but it might have overseen things. Well, okay, but again, if the work that's been done on the kernel is any indication of what's been going to be done in the AOSP, I would presume this is stuff that's going to gradually make itself its way through. Aside from the conversion of the whatever MKs and BPs into eventually Bazel stuff on an automatic fashion by the tooling that's there. Yes, okay, good. Thank you for asking. So I sort of, instead of doing slides this time, I sort of like, because usually what I did is you see those rough notes that I got there? I sort of started with those things, and then eventually sort of put them in slides, and I started doing the slides, and it's like, oh, gee, okay, I'm sort of like going to spend like hours doing just layout, and I'm not sure the layout sort of adds anything to the presentation. So let me figure out a way to make all these text files and screenshots and stuff available to you in a reasonable fashion, and I'll put that in the presentation. Just give me a day or two and I'll figure something out. And I'll put in the description of the YouTube presentation. And yes, you're welcome. Glad you liked the presentation. All right. So with that, folks, thank you very much. I'm going to sign off. If you watch this in the future and you have any questions, try to put them in the sort of comments there, or if you know better about many of these things, which I presume you will, then please do also add this in there. Welcome to sort of, I'm personally an eager learner, so if you know something I don't, I'm more than happy to learn for you. All right, thank you folks, take care and see you soon.